Okay. Hello everyone, welcome to Code Enzyme, and in this video we will discuss A to E problems of Codeforces around 998 Dev 3. And okay, so let's just start. First is Fibonacciness. Now basically let's say you have 5 integers, so we have A1, A2, A3, A4 and A5. Out of this we are only given A1, A2 and A3, A4, and yeah, basically we can put any number in here. So and we need to just check for Fibonacciness, and Fibonacciness is defined as when AI plus 2 is equals to AI plus 1 plus AI. Okay, so basically you need to check for these three cases. So yeah, and how many values can you put in here? I would say, like, since every number can go till only 100, what I decided was to go from minus 300 to 100 to 300, but you can also go from minus 100 to 100. That should also work fine, I guess. Okay, so let's just see the code. So in here, what I decided was I went from minus 300 to 300, and basically I just brute forced it, and I just put all the numbers. Like, I just tried putting every number from minus 300 and to 300 and try to maximize my answer, and whichever was the maximum I just printed it. Yeah, so I didn't really give it much thought how which number do I have to put. I just brute forced it because the constraints were really small. Okay, let's move on to the next problem, that is Farmer John's card game. Farmer John has a deck of n into m cards numbered from 0 to n into m minus 1. He distributes m cards to each of his n cows, and Farmer John wants the game to be fair, so each cow should only be able to play one card per round. So yeah, I mean, you can read the problem statement on your own. Basically what this problem is trying to say is, let's say you have your n cows, so c1, c2, c3, c4 till cn. Okay, and these cows have a lot of cards, like they have card 1, card 2, card 3 till card m, and every cow has m cards. Okay, and initially minus 1 is on the pile, and you can only put the next card, the next just greater number than the last card that was in the pile. Okay, so what I observed was, since we want to put the cards in this order only, 0, 1, 2, 3 till n into m minus 1. Okay, so like, if this is the first cow, this is the second cow, this is the third cow, then this will be the nth cow, and then again the first cow will come, right? So that is how this game is being played. So what I decided was, okay, let's first sort all the arrays like this. So I decided to sort them as I was taking the input. So let's say I had 0, 4, 2, so I sorted it, then it became 0, 2, 4, and then I had 1, 5, 3, I sorted it, it became 1, 3, 5. Then I went on to traversing it like this in the y direction, so 0, 1, 2, 3, 4, 5. So if I was able to successfully traverse it from 0 to n into m minus 1, I will say, like, okay, check is true. So first I sorted it like this, then I sorted it like this, and then if I was able to fully traverse it in this direction, like I was able to traverse it in this direction like this, then I will say, like, okay, it is correct. And after that I just have to map these to the original index and then print it. So that was the approach. I will just show you my code. Since it had a lot of sorting and like that, so I decided to do this in Python, because that will I'm not sure, like I thought it will be easier to do it in Python. Yeah, so I just sorted it, and then in one array I simply appended it, and in the other array I mapped this x to the index that I am currently at. After that I traversed everything in the y direction, and if I was able to do it, I will say, like, check is true. If check, then I simply have to print the indexes in the sorted like that. Yeah, so let's move on to the next problem. It is game of Mathletes. Alice and Bob are playing a game. There are n is even integers written on the blackboard, represented by x1 to xn. There is also a given integer k and an integer score with initially 0. The game lasts for n by 2 turns. in which the following events happen. Select an integer from the blackboard, erase it, and let Alice choose the integer a. So Alice chooses an integer a and Bob chooses an integer b. If a plus b equals to k, then we add 1 to the score, right? Yeah. Alice is playing to minimize the score and Bob is playing to maximize the score, assuming both use optimal strategies. What is the score of after the game ends? Now, okay, so now this is actually very similar to the two-sum problem if you have actually solved it on LeetCode. So this is very similar to the two-sum problem. So if you have not solved it, I would recommend you to actually just go and solve it and come back. Okay, now let's say you have the elements in sorted order. Okay, so let's say a1, a2 till an. Okay, now since we want to create a sum of k, now Alice will try to maximize the score. So Alice is a girl, right? So she will try to take the largest number possible, right? And since Bob will try to minimize the score, he will try to take the minimum number. Now why does this work? Because let's say you have a number k. Let's say we have some arrays like 1 1 1 2 2 2 3 3 3. Okay, and 4 4 4 and so on, like let's say 5 5. And if my k was equals to 4, it makes sense that I choose this, because that will make Bob lose some of the points, right? So what will happen now? Since what will happen is, let's say I have this, I choose this, then the point is actually the point is simple, that we just need to calculate the number of pairs where ai plus aj equals k. Okay, and if that is the case, then I mean the number of pairs, number of L and R pairs such that ai plus aj is equals to k, maximum number of pairs such that ai plus aj equals to k, then that will give me the answer. And one of the ways is to simply just sort them and like take this as L, take this as R, and al plus you can simply do like if al plus ar is equals k, then simply answer plus plus. Okay, if it is greater than k, then simply do r minus minus. If it is less than k, then do l plus plus. And if you do this, you will realize that I mean I kind of I was in a hurry, so I just did that, and I realized that the answer was actually same, and I could not find a test case where this was failing. So yeah, I just implemented that and using the two-sum problem, and it kind of passed the question. Okay, yeah, so I am not able to actually prove it how this is done and how this is congruent, how this is equivalent, but yeah, that is the solution to this problem. Let's move on to the next problem, that is subtract min sort. Okay, you are given a subsequence a consisting of n positive integers. You perform the following operation any number of times, and I think I'm not sure, I think this was the one of the easiest problems on this I think it was one of the easiest problem of this whole contest. Why? Because we have, let's say we have numbers a1 a2 till a3 till an, and what I decided, like, okay, let's just do this, like let's take the minimum and subtract it, right? So let's say you have 4 5 4 5 4 5, so 4 5 4 5 4 5 and 4 5. So what I did, I just took the minimum, subtracted them, so this will become 1 4. Then I took the minimum of these two, subtracted the minimum, that will become, then this will become 0 and 3. Then take the minimum of these two, this will become 0 and 2. Then I took the minimum of these two, it became like 0 and 2. Then this will become 0 and 3. This will become 0 and 1. This will become 0 and 4. And now you traverse this way and check if you still have any inversion, like ai is greater than ai plus 1, and if you still have, then the answer is no, otherwise the answer is yes. So I just tried this way and it kind of worked. I'm really sorry, I forgot to read the problem statement for you. Now yeah, so what I did, I took the minimum of the consecutive pairs and then I simply subtracted them in this loop, and after that I just then again ran the same loop and I just checked if we still have this condition. If yes, then yeah, that is pretty much the solution. So that was an easy solution. Let's move on to the next problem, that is graph composition. You are given two simple undirected graph f and g. F has m1 and g has m2 edges. So yeah, let's just see this quickly. This is also one of the easy problems only. So you have f graph and g graph. Okay. So it says like the number of vertices will be constant. Like we have 1, 2, 3, 4 till let's say we have n edges. Okay. Now f has some m1 edges. Like it will have m1 edges, and this similarly this will have m2 edges. Okay. And basically we have we want to determine the number of edges that I have to, minimum number of edges that I have to add or remove, such that if there is an edge if there is a path from u to v in f, if and only if there is a path from u to v in g. So if and if, basically it is a equivalent statement. So if there is a path from u to v in f, then there is a path from u to v in g. So that doesn't really mean that we need to make the graph identical, right? We just need to make this graph look like more of like the connected component should be same, not the exact edges, right? Now let's first see the sample test cases. So first of all, I mean, just to make you understand the question, let's say in the f graph we have 1, 2 and 3. The edges are 1, 2 and 2, 3. Okay. And the g, let's say 1, 2 and 3. Okay. So I mean, with this test case I will also try to explain you my solution also. So what I did was like in this we also have 1 and 3 connected. Okay. So first I actually just stored the these edges so I can traverse them later. What I did was I made a DSU. Okay. So I made a DSU to I made one DSU as G, so let's call it DSU G, and one DSU as F, so let's say DSU F. Okay. And first I traversed the edges of G and tried to find the connected components of G. So like 1 and 3 are connected, so I will merge them and like that. And then I traversed in edges of F. Like okay, I saw first edge was 1, 2, so I checked the DSU of G if these two are connected in graph G. If they are not, then I will simply remove them. Okay. Then and this checking will be done in big O of 1, right? Yeah. So then I look for this edge. So my answer is currently 1 now. Then I look for this edge 1 and 3. I think I made the diagram wrong, sorry about that. So it was like this. Okay. Then I check the edge 2, 3 in this G graph, right? And they were also not connected, so I will remove it. So my answer will become 2. Okay. Now what will we do? Now what you can do is like first of all, what you can do is you can first check the connected components, like let's say this is one connected component and this is one connected component. So this is connected, this connected component is let's say represented by 1, this connected component is represented by 2. Okay. So what I will do is like I will try to I mean, let me see. So we have 3 edges, like 3 nodes, like 1, 2 and 3. So I will try to find the parent of these edges in both F and G graph. Okay. So for 1, what is the parent in F graph? So currently it will be 1 only, and for 1 what is the parent of n? Let's say 1 only. Okay. For 2 it is 2 only, for 3 it is 3 only. For 1 I decided that 1 will be the parent, So let's say this is 1 and this is 2, right? Now now what we can do is we can traverse in, like we see that 1 was common, right? So let's make a set like this. So 1 had common 1 and 3, 2 had common none, like 2 had common with 2. Okay, yeah. So since 1 is connected with these two, right, like these are different, that is why we need to connect these two components, right? So we have to add like let's say there were more, like 1, 3 and 4, if there were more, then I had to add 2 more edges, right, to make these connected. Like if you have n edges, n nodes, let's say 1, 2, 3, 4, then you need at least n minus 1 edges, right? 1, 2 and 3 to make them connected. So that is why we need at least n minus 1 edges in this to make them connected, right? So I will just show you the code. Yeah, so first this is the standard DSU, and then obviously we need to make 2 DSUs, and F edges and G edges I tried to first merge them. After that we have edges F, and first time I'm just appending it to the array, like, yeah. And then while traversing in the G graph, I'm also finding the connected components like this. So in the G DSU, I'm trying to merge the nodes. And then once this is done, I will again traverse in this for loop like this. So if they are not connected in the G graph, then I don't really need to then I need to remove this edge and go to the next one, right? And if they are connected, then I will also merge them in the F graph. After this, what I need to make something like this. So there might be the logic behind this is actually, like, let's say there is a graph G. Okay, in this graph G, let's say we have a lot of nodes which were actually connected, like 1, 3 and 4 is connected, and 2, 3 and 5 is also connected. Sorry about that, this 3, let's make it 6, and let's also say, like, let me think, let's also say 7 is and 8 are connected. Okay, now let's say your F graph looks something like this. Sorry about that. Now F graph looks something like this, like 1 and 4 are connected, 6 is not connected. Okay, and like 2 and 2, 3 and 5 are also connected. Let's say 7 and 8 are not connected. Okay, so if your F graph is looking like this, clearly we need to make some we need to add some of the edges, right? We either need to add this or this. We don't really need to do here. We need to add at least 2 edges. So how do we find this number 2, right? So let's first assign the parent. So let's say 6 is the parent, let's say 2 is the parent, and let's say 7 is the parent. Okay, so clearly if I have around 8 nodes, right? So let's say 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and we will just write down what was the we'll just try to find out what is the parent. So in F, let's define it like what the parent was. So let's say this is the one, this is the, I mean, you can do it differently. So this is 1, this is the parent of 7, this is the parent, and this is the parent. Okay, so now if we try to note down the parents of F, so we have 1's parent is 1, 4's parent is also 1, right? 2's parent, 2, 3 and 5 go with 3, so 3, 3 and 3. 6 is itself, and 7 and 8 are also with themselves only. Okay, so that is the case with F graph, FDSU, and let's also try to go with for G1, the GDSU. So for G, we have something like 1, 6 and 4 are with 6, right? So let's say 1, 6 and 4. Okay, and the next connected component is 2, 3 and 5. They have 2, so 2, 3 and 5. Okay, and the next connected component is 7 and 8, and they have a parent of 7. Okay, now if you see, like if what I want is this parent, like if these two are connected graphs, like they are exactly the same way connected, then each of like the parent set should be same. Like for this whole like for this whole connected component, the parents of these all in this graph should be same. For this whole connected component 1 and 4, the parents of these two, sorry about that, I'm really sorry, it should be like this. For this whole connected component, for all these three elements, the parents of these three in the F graph should be same, right? So what we can do is let's just try to create a set. So what will happen is for 6 okay, so clearly we have less number of elements here, right? So for 6, the parent of 6, we have how many? We have 1 and yeah. So if I see like this 1:1 mapping, then it means that this component was connected, right? Six. Why am I? Okay, so we have 2 actually, 1 and 6, right? So clearly the sixth, the component which is represented by 6 in the G graph is represented by 2 components in F graph. So clearly we need to add one edge, right, in F graph. And if I just connect these 2 edges, then we are done. Similarly, if we can see, like for 2, 2 is mapped to 3, 2 is mapped to 3, 2 is mapped to 3. So there is only one unique element. So now we no need to add. And when I look for something different, like say 7, 7 is mapped to 7 and 8, right? 7 and 8 in the F graph. So we need to create an edge between them. Similarly, if there are more than one nodes, let's say n1, n2, n3 till nn, so clearly we need n minus 1 edges, because you will at least need n minus 1 edges to make this whole thing connected, right? So yeah, that was the intuition behind it, and a really good problem. So what we will do is we will create a map of int and set int. You can also create something like unordered map and like that to avoid the log and time complexity. And but the core idea is like this only. I just wrote this code to make it look more visually appealing. I haven't actually tested it, but yeah, the idea is this only. Actually, we will just test it right here. If the contest allows. Yeah, it is in practice mode. Let's actually just test this code. So we have E graph, and let's submit this. I mean, I did some formatting and all, so that it will, yeah, it is passing, I think. Okay, so it got accepted, and I hope you were able to understand the solution. And if you were able, and if you learned something new, kindly like this video, subscribe to the channel. I will see you guys next time. Thank you.